Hi student. Yeah, a lot of students actually asked me to make about this topic, so I decided to make a short videos about search. Actually, if you are not SBM student, you're IG student or STPM or A-level student, you might be quite familiar with search. And recently, I guess is this year actually the government add this cert into the Form 4 MF topic together with indices and log. So over here, I'm going to do a quick introduction of cert, and basically I will teach you how to do this part in this topic. Right, I googled a little bit. They have a definition of cert. They call what is something like irrational root of a positive rational number. Yeah, I know it's very hard to understand. Basically, what they're trying to say is you have a irrational root. That means after you do the root already, it can be n root, but then in SPM over here or IGCSE, you will only learn about quadratic root. So quadratic root basically means quadratic cert. I mean quadratic cert. That means here must be square. It must be square root. Okay. So but then we call it cert. It can be any power here. But then over here in SPM we only focus on square root. So that means inside the square root must be a rational number. Rational number means those integer number. We just imagine it's a positive number. Okay. And then my answer must be irrational. Must be irrational. So that means inside the square root, this one must be positive rational number. Just in case you do not know what is rational or irrational number, in short is irrational number will give you infinite decimal, and at the same time it cannot be written in the fraction form, and then the fraction must be something like a over b. This one we call it as a fraction, right? The fraction a and b must be integer. So that's me, because some students might argue 1 over 3 have infinite decimal, isn't it? Because it's 0.333333333. But then is this one an irrational number? No, this one is a rational number. Because what? Because we can write in a fraction and 1 over 3 both is the integer number. I just give you another example. We know pi is an irrational number because you have infinite decimal for pi, something like 3.14159 and so on. Okay, so, but then if I write pi over 3, it seems like a fraction, what? But is this one is a rational number? No, because in order to call it as a rational number, we must be able to form a fraction, and this fraction must be numerator and denominator both must be integer, and pi is not the integer. Yeah, okay, so this is the reason why pi over 3 is not a rational number, even though it can be written in a fraction. Okay, even though until now you still do not understand what I'm talking about, it's fine. Even though you do not understand what is cert, you can still do the cert topic. So in short, whenever we call it as a cert, after square root already, you will have infinite decimal. I give you an example to make the understanding easier a little bit. Example, let's say I have square root 4. Square root 4, what will you get? You will get 2. Isn't it? Is 2 infinite decimal? No, right? So this doesn't call it as a cert. Let's say I have square root 2. Square root 2, will it give you infinite decimal? Yes, because if you type in the calculator for square root 2, you kind of will get 1.4142 and so on. Do you see you have infinite decimal? Then this is what we so-called cert. So basically in SPM or IGCSE, you will only focus on the what we call quadratic cert. Quadratic cert means what? Quadratic cert means your square root here, the power is always 2. Yeah, because if you call cert, here can be any power as long as it's positive integer bigger than 1. Yeah, but that one doesn't matter. So right now, at least you need to understand, if you do the square root already, you doesn't get the infinite decimal, it is not the cert. If you do the square root, any number will give you infinite decimal, then it is cert. So I can give you more example like, okay, square root 3, yeah, it's infinite decimal, square root 5 is infinite decimal, square root 6 is infinite decimal, and so on. Okay, like square root 9, is it infinite decimal? No, because you will get 3, right? So, yeah, now at least you need to understand what is third and what is not the third. Okay, so basically in this topic, you only focus on two things. One is how to simplify the third. Second thing is how to do the rationalized process. Okay, so I'm going to focus these two things here. So the first thing we need to learn is, how to simplify. Okay, in order to simplify the third here, you have to know what is perfect square number. So perfect square number, that's been like 1 square, 2 square, 3 square, 4 square, 5 square, we call perfect square number. So we have the perfect square number is something like 1, 4, 9, 16, 25, 36, and so on. Okay, because what? Because when we square all these perfect square number, I will get a whole number or integer. Okay, so example, today if I want to simplify square root 12, of course, if you are using the modern calculator, like this model or even, I think a lot of you have this one, silver color one, both of these calculator actually will straight away give you the answer. As long as if you type the square root 12, you type in the calculator will tell you it's a 2/3, will be 2/3. But how actually calculator give you this answer? So this is what we want to learn today, is how to simplify like square root 12. So, okay, one of the very fast tips is 12, okay, any perfect square number multiply other integer actually give you 12. So, real quick, I know 12 basically is 4 times 3. 4 times 3. Okay, 4 is the perfect square number. You might ask, why can't you choose 6 times 2? The problem is none of here is a perfect square number, then I cannot simplify. So in order to simplify, I must find one of the perfect square number here. And then the square root rule tell me what? If they are multiplied here, I can simplify as a square root 4 multiply square root 3. Because we know about third rule, right? If square root A multiply square root B, we actually get square root AB. So this is one of the law for square root. So at the same time, if they are multiplied, I can separate them like this. And then what is square root 4? Because this is perfect square number, so square root together with perfect square number, we can simplify as 2, isn't it? So this is the reason why I get 2/3. Okay, if you change to the 6, 2, because 6 itself you cannot simplify, I mean square root 6. And square root 2 itself you cannot simplify, as well. So if you change into 6 times 2, it doesn't help at all, because the purpose of this part actually you want to simplify it. So maybe I can give you more example. Yeah, example, now if I want to do about square root 18. Okay, for 18, right now you have to ask yourself, any perfect square number multiply another number actually give you 18. So I know 18, of course you can say, what if 1 times 18? You get back square root 18. It doesn't help. So we never use 1 here, okay? So 18 definitely I will choose 9, because 18 can divide by 9, you got 2. So I know, okay, it's 9 multiply 2. And then you will realize I have a habit. I always do the perfect square number first, then only other number. Of course you can do 2 times 9, because what? Because later I need to simplify like this. Square root 9 multiply square root 2. Because square root 9 give me 3 square root 2. Square root 9 is 3, square root 2 I copy. This one they call mixed third. So basically you have a whole number and together with a third. And we always write the whole number first, and then we write the third at the back. So this is kind of the pattern. So right now, at least I hope you understand how you can simplify this one. Sometimes the number is too big, then you kind of need to think a little bit. Something like, okay, today if I have thirds, I don't know, maybe 600. So at least I understand 600 is basically 100 multiply 6. And then square root 100 will give me what? Will give me 10, right? So this is 10 third 6. Or you can say 10 square root 6. Okay, so yeah, this is how to simplify. Okay, then we go to, yeah, this part is the most important one. They call rationalization. Okay, so what rationalization here do is, they're trying to avoid your denominator have the square root. That means the mathematician actually find out if your denominator of your fraction have the square root, you will make the whole calculation become a lot more complicated. So this is the reason why they doesn't want your answer have the square root at the denominator. So, and then you can check, whenever you use the calculator to solve, right, the calculator will never leave the denominator square root. I give you an example. Let's say we have 2 square root 2. 2 over square root 2 is a fraction. If you type 2 over square root 2 over square root 2, 2 over square root 2 in your calculator, you realize your calculator will straight away tell you square root 2. If you have the modern calculator, if you use the old model, I'm sorry, you can't do this experiment, but then I will explain how you get this thing. But if you type square root 2 over 2 in your calculator, square root 2 over 2 in your calculator will tell you square root 2 over 2. So what is the trick here is, you can see here, the calculator will leave this form into this pattern because of what? Because your denominator here doesn't have square root, or we call it doesn't have third here. So therefore the calculator can accept this form, they will give back you the same answer. But it's 2 over square root 2. The calculator cannot accept the denominator have the square root here, so the calculator will simplify for you, then tell you the final answer is square root 2. So how actually the calculator do the simplification is something like this. In order to avoid the square root, the easiest way is what? We square it. So if you want to square it, this is what you can do here. So in order to make the square root 2 square, the easiest way is, we know we can multiply square root 2. So I multiply square root 2 here and multiply square root 2 on the top. Because what? Fraction, right? You cannot just simply multiply any number at the denominator only and ignore about numerator. So whatever you multiply at the bottom, you make sure you multiply it at the top. So after that, what you will get is, okay, top you will get 2 square root 2, isn't it? Because 2 multiplies square root 2. You realize I always write integer first, then only write third. You please form this habit, will make you solve this topic easier. So over, what is square root 2 times square root 2? You will get square root 2 square, isn't it? Then square and square root I cancel out, I left a positive 2 here. And 2 here I simplify, I get square root 2. Okay, so if your denominator is any square root number only without plus and minus here, then what you want to do the rationalized process is, you multiply it back to the whatever you have in the denominator, you multiply the same thing back into it. Then you can get a square. After you get a square, you can simplify it with a square root, and then you will get without any third at your denominator. But what if you have something like this? What if you have something like, okay, 2 over 1 plus square root 3. Okay, I see square root at the denominator. I'm very unhappy. So therefore, I'll try to simplify it. Then I need to think, how can I get rid of the square root 3 here? Because yeah, I don't want my denominator to have square root. And you might say, sir, it's quite easy what? You multiply back the same thing. Let's see. If 1 plus square root 3, if I multiply back the same thing, 1 plus square root 3 here, if I solve this one, I actually get 1 plus 2 square root 3 plus 3. And I simplify it, I get 4 plus 2 square root 3. You see, at the end, I still have the square root 3 here. I doesn't solve it at all. So if I multiply back at the same thing, I mean, if I have 1 plus cert3, and then I multiply back the 1 plus cert3, at the end, I still got cert3 at the bottom, which is not what I want. And some students might think, so what if I multiply square root 3 only? Okay, let's check it out. If I have 1 plus cert3, if I multiply square root 3 only, I multiply first one, second one, and I will get square root 3 plus square root 3 square, which is 3. I still have the square root 3 here. You realize I doesn't solve it if I multiply square root 3 or I multiply back the same thing, because at the end, my denominator still has the square root over there. So, the mathematician actually find out one method to solve this thing. They call it as the conjugates. I hope I pronounced it correctly. Yeah, they call conjugates. So what conjugates do is, you already learned this one at your Form 2 or Form 3, is one of the easiest way to square both of these one if doing a plus b multiply a minus b. Because if we have a plus b multiply a minus b, what we will get is a square minus b square. So that means if I have a plus b, I multiply a minus b, this is the only way I can square my a and square my b. Then you will be very happy to find out that if I square 1, I will get 1. If I square root 3, I will get 3. So this is the only way to solve your denominator to make the cert, to get rid of the cert. Okay, so what I want to do is, because of this conjugates law, so I know if I have 1 plus square root 3, I have to multiply back the same thing, but it's 1 minus square root 3 in order to make myself get rid of the cert at my denominator. So what I want to do here is, I will multiply 1 minus square root 3. And then here I will multiply 1 minus square root 3. So from here, because of this law, a plus b multiply a minus b, I actually get what? A square minus b square. My b is a square root 2, right? Square root 3, right? And then top is basically, I just multiply normally, which is 2 minus 2 sub 3. I just multiply 2 for both of them. Alright, then for the denominator over here, I can simplify it, isn't it? So 2 minus 2 square root 3 over 1 minus 3. Because square and square root I can cancel out. I get negative 2. And then I can simplify further by factorize out the 2 and then solve the negative thing again. So you will get square root 3 minus 1. Yep. Okay, maybe I don't want to skip this step because some students will say, how teacher you get this one straight away? So basically what I will do over here is, I factorize out the negative 2 from here. So if I take out the negative 2 from the top here, the 2 actually will give me what? Negative 1. The negative 2 I factorize out, I get positive square root 3 over negative 2. Then I simplify the negative 2 and negative 2, I get square root 3 minus 1. So this is how I get the answer like this. Of course, in the exam, you might have something more complicated a little bit for you to simplify. But then as long as you follow the rule here, whenever you get for the denominator is plus, then you multiply the minus version of it. If this is minus, you multiply the plus version of it. Then you should be able to always get the answer. Okay, so but by ending this video, maybe I just add one more complicated example so that you can understand better. So let me just add one more example here. Okay, so yeah, I can actually give myself any example I want, but yeah, something like, okay, 3 square root, I don't know, 3 square root 3 minus square root 5 over 2 square root 3, I don't know, any number, plus square root 5. Or want to make it crazy a bit, plus 3 square root 5. Okay, if I were to solve something like this and then they will ask you to rationalize this this equation and leave in the simplest third form. So, okay, so I cannot leave my fraction like this. And there's a loss of square root here. So my first objective is I want to rationalize my denominator. So I say whatever you have it here, you multiply the negative version. So this one I assume as my A, this one as my B. So I have A minus B. So I have to multiply for top and bottom, A minus B. Okay, we solve the denominator first. So A plus B multiply A minus B. What you will get? You will get A square minus B square. And then on top, I will just multiply one by one. So square root 3 multiply, 3 sub 3 multiply 2 sub 3. So what we will get is 3 times 2 give me 6. Square root 3 multiply square root 3 give me 3. This is bracket, not 1. Okay, then this one multiply the next one. 3 times 3 will give me, 3 times negative 3 will give me negative 9. Square root 3 times square root 5 give me square root 15. Because just imagine square root 3 multiply square root 5 is actually equals to square root 3 times 5. Then you will get square root 15. Okay, then the next one, sub 5 multiply this one will be minus 2 sub 15. And then negative sub 5 multiply this one will become plus. Negative times negative is positive. 3 times 1 is 3. Square root 5 times square root 5 is 5. Okay, then the last step is, not the last step, I guess it's the last two steps. I will just simplify the denominator here. This one, what if I square this thing? 2 square will give you 4. 2 square will give you 4, right? And then square root 3 square will give you 3. 4 times 3 is 12. Minus 3 square will give you 9. Square root 5 square will give you 5. 9 times 5, 45. And then top, we have some integer here, 18 plus 15. 18 plus 15 will give you 33. Then I solve this thing, these two things. And then minus 9 sub 15, minus 2 sub 15, minus 11 sub 15. 1 5 sub 15. Alright, then last step, maybe I can factorize out 11 on the top. And then this one will give me 3 minus square root 15 over denominator. I will just minus it. I will actually give negative 33. And then 11 and 33 I can further simplify again, become 3. And I don't like my denominator have negative, so normally I will do the one last step is multiply the negative for both here. Multiply negative 1 here. So my final answer should be square root 15 minus 3 over 3. So I just want to make denominator without negative. This is my hobby. This is my way of doing that. But you can leave the answer like this, I guess. Should be no problem. As long as your denominator have no square root already, then everything should be fine. Alright, so yeah, I hope these few examples actually can help you understand better about these third topics. So anyways, if you have any comment or if you have any question you don't understand, yeah, you can comment at my post below. I will try to reply you if I have time. If you have any other video you want to suggest me to make, you can go to my Discord. There's a channel there called Suggest Video, something like that. Yeah, or ask for a video. I'm not sure what title I put already. Then you can go there and suggest. Alright, so I'm going to see you guys in the next video. Bye bye.